Okay, so this is just going to be a quick demo of telemetry visualization and fault analysis tool that I've been working on. And this is really nowhere near close to done, but hopefully it should be interesting to take a look at the beginnings of what we have here. So I'm going to go over the interface, and then I'll show a little bit of the back-end data that runs it. What we have here is this is a full monitoring panel for data that's coming in. You could be live data coming in from a vehicle that's currently operating, or it could be saved data that we're replaying to reanalyze. This data right now is being streamed over the network. It's been pre-recorded, but it's being streamed as if it were live. You can see here on the right, in this monitoring panel, we can see the current time, and we can also see just the values of various different channels, X rotation, Y rotation, cores in use for the processor, etc. You can sort of pre-program what channels you want to look at. This is very common in data dashboards. On the left here is sort of a new innovation related to fault diagnosis. It seems like one of the major issues with fault diagnosis is finding connections between different data channels, seeing what influences what and how everything's categorized. And this is something that not a lot of effort has been put forward regarding with my experience with and in the research that I've done about interfaces for this sort of problem. So what I've done here is divided the different subsystems into categories and made a navigation tree that further divides those subsystems, sub-subsystems, and you can see you can expand parts of the tree here, and you drill down to the leaf nodes at the very end, and these nodes are actual data channels, left motor current draw, left motor voltage. And if we click on these, we can add live data to our data feeds. You can see right here on the right, we're looking at the data for these channels over time. Perhaps showing a few too many digits here, so it's kind of hard to read this, but this is all of the data over time, and we can watch it and we can look for anomalies in those data charts. The other two components we see here are very similar, but they're both related to finding the correlation over time between channels. If one channel goes bad, has some issue, it might be interesting and useful to see what other channels were correlated positively or negatively with that channel, because maybe they didn't have an issue, but it's useful to look at if some anomaly happened that wasn't picked up automatically. And you can see here, this is a correlation matrix where the correlation between pairs of channels over time is visualized using blue or orange. You can see the columns here are channels, and the rows are the same channels. And so if we hover over one of these, we can see here, right here, we're looking at the correlation between internal health metric and total CPU usage. You can see the correlation is changing the correlation matrix, but it's not much. It's light orange or light blue, pretty much almost zero correlation. But you can see here in this diagonal here, we have bright orange because every channel is going to be exactly correlated with itself. Hopefully we would see that color as well if some issue occurred, and we could find channels that are correlated with each other. And you notice that this row and this column are blank. That's because for the Pearson correlation coefficient, this one channel here doesn't have any standard deviation whatsoever. It's always the same, and the PCC is undefined for standard deviation equal to 0. So that's just an artifact of our algorithm. We might change that later. One last thing, we can make a fault occur here, and I'll just trigger one. And I'm going to pause it. And you can see here that the navigation tree is updated to show this fault. You can see fault overacceleration has occurred, and these are the 3 affected channels. These channels are the ones that were affected by the rule that caused this fault. And you see this panel right here, it's gone to red, and it's giving us information about this. It says there's an overacceleration, and this occurred at this time. And the trigger, which is kind of in our own domain-specific language, says the mean of these 3 channels, X, Y, and Z acceleration, is greater than 5 Gs. And then we have a little bit of notes that some operator might be able to add to this specific fault and say, hey, when this occurs, maybe take a look at this because this could be the cause of it. This is just a way to capture expert knowledge, which is something that needs a little more attention in these interfaces that I've seen. So this is a general view of the interface, and we're hoping to add to this in the future.